Up next, we have Vukasin Vukoje. Vukoje. Vukasin
Yeah,
Vukoje. Vukasin.
you said very well,
Oh,
but
hey. I know I'm butchering your name. I'm so sorry. I'm
it's
just gonna do a quick little intro, and then I'll let you take it away. Okay.
fine.
Vukasin heads ecosystem growth at Protocol Labs. He previously founded Tenderly and is now also advising as lead product of tokens and smart contracts at Cardano. A perhaps interesting story about Vukasin and how he ended up at CSCON1. Myself and two other colleagues randomly stumbled upon Vukasin at a coffee shop in Lisbon at the end of LizCon a few short months ago. Even though he worked at Protocol Labs, a partner of ChainSafe's, most of us had never met before. Nevertheless, he stunned all of us with his deep technical knowledge and passion for decentralized infrastructure. The moment I met him in Portugal was a sort of welcoming party for me personally at my first crypto conference ever. This was the sort of caliber person I was to expect to liaison with moving forward, but also the sort of open and welcoming soul that would be willing to just have random crypto conversations with a bunch of nerds in a coffee shop. So Vukasin will be talking today to us about decentralizing the data center. Vukasin, take it away.
Thanks for inviting me and such a great introduction as well. So yeah, today I'm going to talk about the Web3 infrastructure. But when I say Web3 infrastructure, that's very general and ambiguous. So I'm specifically going to talk about how we are seeing the data center evolve and allow like multiple networks to like connect through the data centers that are actually like being run with what we call miners today. So I'm going to share my screen and go through these slides. So yeah, this is not necessary as I got the intro already. Yeah, so where we are today with data centers. So most of the data centers today are owned by big tech companies, either for like internal use for training large amounts of training models with large amounts of data for internal uses, or renting those through cloud services that are mainly like owned by those big cloud providers and tech companies. So on the other side, we have very few still remaining data centers that are trying to like somehow compete just with infrastructure. But slowly, like all the medium ones and small ones kind of died off because the business models where you're renting or selling a particular server for a particular time, like that doesn't work anymore. Because what we're selling today is abstractions on infrastructure that is running on the cloud. And this is where the cloud providers, of course, dominated. And the smaller like data centers, which by nature were only basically real estate businesses rather than tech businesses, couldn't compete at all. And many of them had to basically shut down. And now we are slowly, in my opinion, seeing a renaissance in data centers again because of a couple of reasons. First of all, there is like a shortage of like chips in general. So like any hardware that you had left from like the past couple of years, that's still good. And it's still going to be good for a couple of years. And on the other hand, we are also getting to a point where we are able as a humanity to share the resources between like things that are not necessarily owned by big corporations, meaning that we are able to like share computing resources with things like Golem and networks that like a cache that are actually like allowing us to like have an abstractions over those. The sad part is that currently the situation is that probably less than 10 organizations are controlling all of the data that we are storing as humanity, mainly because of those development tools that were basically of each other, meaning that we have, for example, the VM and some hypervisor that is actually like managing those VMs on hardware that is owned, for example, by AWS. Development tools, like initially those were just load balancers, but then those became more complex where you had like managed Kubernetes clusters and things like that, where you're getting to a point now where the developer is even aware of what's happening under it. But the issue of those is that we are now at a point where one developer can actually like build something that is hyper for like hundreds of millions of users. but that developer has like no clue on how that is being executed on the machine itself. And the issue is that when we are trying to like change the paradigm, how we are actually doing computing, it's very hard to convince someone to put like 10x the effort just to build something that is not being owned by Google or all the other tech companies. Because of that, when we have like a new developer entering the the entire software ecosystem, the default thing is going to be to go to like some pass for your backend, and maybe even use something like Firebase, and not even noticing what's happening in the background, which is sad because that basically puts us in a spot where it's going to take us much more time to actually get in a position where we can change it. So instead of taking us a couple of years just to develop the things, we need to like spend probably 5 years to get to a point where it can be fully competitive with what we the issue with centralized storage is not because it's centralized, it's because of the way that that infrastructure is being managed, and because of the legal constraints that you have when you're basically running a server. So meaning that by default, like all the data that you're storing on your servers, in a way it's yours. Of course, you can have some terms of use that are like massaging that a bit, but at the end of the day, you are controlling that data. And very few companies like are controlling like massive amounts of data, also sparse all across the globe, giving a lot of power to particular like countries, which is becoming very problematic in the past year. And that is getting us in a spot where we are like risking to get in very like unpleasant situations where we have particular countries that might have like a reason to like detach themselves from the internet, or where we have like very strong firewalls that are actually like preventing us from having an internet that is neutral all across the globe. But on top of that, also like the development tools that I mentioned are also like inheriting those properties and giving like the same legal and ownership of the data constraints to the final product that those developers are building. What we do instead with decentralized storage is we want to create an equal playing field for all the participants, where like the data center operators, the developers, the users can like access the protocol in the same way. Because of that, we have very strong rules that are dictating how that protocol works. And because of that, we are able to align all the incentives in a way that everyone starts thinking about how to like maximize the value of the ecosystem, rather than how to extract most of the value in the single transactions that are happening. Meaning like, I'm not selling anymore like a server for, or like a VM, or like a cluster for X, and trying to like capture a percentage of that X. Rather, I'm thinking about like, how am I gonna store this data set? Can this data set be leveraged by other users? And if that data set can be leveraged by other users, I could also like possibly think about creating some data DAO around that data set, and maybe monetizing the fact that I have like curated that data set and figured out what data set is important for humanity to store. Also, a very important thing that is actually like bringing the renaissance in the traditional data centers is the fact that now we don't need to like have centralized tools that are only running on the cloud providers. Rather, we have tools that can run on any data center operator, because those are tools that are just built for the ecosystem as a whole, rather than a particular entity. And that is going to speed up in general, like the progress that we are going to be making with the storage and computing by a lot, because now I'm not competing between tools. Now I'm that are actually teams that are actually building things together to actually and like merging all the efforts into one. So Yeah, in order to get to a point where we can actually change that, what we need to do is we need to focus on three particular things. On today's focus on the last one. But other than the infrastructure, we also need to have like the tools that developers working, for example, on mobile apps have to use in order to leverage that infrastructure without having to worry about and having like a nice abstraction layer around the retrieval and storage and networks. Of course, we need to bridge storage with computing. Otherwise, storage value is very questionable, and also like computing value per se is very questionable as well. If we need to like retrieve and store data from the computing network to the cloud all the time. And at the end, we also need to make sure that that is actually like working on every data center, also known as miner in. So yeah, how do we actually do it? So we need to reduce the barrier to entry to participate as a Web3 data center operator, meaning that as a miner, I can't really like do DevOps work and figure out like how to provision particular nodes on which particular machines and so on. So that needs to be abstracted away for the miner. This is something that I'm particularly focused on by incubating a team at Protocol Labs. Also, we need to abstract away the storage and retrieval. Historically, everyone knows that storing a storage deal on Filecoin was very hard. And this was also because we tried to make it such that it is very flexible and everyone can basically do whatever they want. And we have like a couple of implementations on how to actually store those storage deals to Filecoin ideally, how to like split the sectors and what are the ideal ways of actually like doing those storage deals with those sectors on the network. But yeah, that's a core problem that now we think we have figured out. And then what we also want to make sure is that because of the high collateral requirements that the Filecoin network has, with good reasons, because we want to have a very stable base of data center operators that are actually going to be there like no matter what. And the best way of doing that is by having them have like a lot of collateral that they are going to lose in the case of them not like obeying the rules of the protocol. On the other hand, we also need to massage that a bit. We can't really have that barrier to entry that high. Otherwise, the network is not going to grow fast enough to allow humanity to have like the largest storage network in the world. So what we do is we leverage things like reputation, both on-chain and off-chain reputation, to just reduce the risk by a bit and allow, for example, users in DeFi to do revenue share with those miners, or to allow particular institutional funds to invest in particular data centers because they see all the logs that those data centers have provided, and with some statistics we can see that those are likely not to fail. So that allows us to accelerate the growth, but it also allows us to leverage that anchor collateral that is there to onboard the other networks. Because if you think about what's necessary for you to do some computing on that data center, in the beginning it's gonna be like you need to figure out like how to make sure that that miner is reliably always running that compute. So instead of like building your own like protocol that has like collateral requirements or other like mechanisms on how you're incentivizing that miner to behave rationally, you're instead relying on the collateral that is already stored on the Filecoin network. And we have seen that this was particularly useful for some rendering networks, some computing networks that did not actually have like collateral requirements at all. So where we are today. So we have 13 exabytes of storage capacity, and this is spread across the globe. But of course, there is more in Asia because it turned out that like in Asia, it was much easier for miners to like buy equipment and figure out like how to mine. And also, since that started very early on in that ecosystem, it spread very fast. And that growth is something very similar to what happened back in the days. Bitcoin mining was like very popular, or Ethereum mining. Like it grows so fast in a couple of months, and then of course it stabilizes when like more and more miners get in the ecosystem, of course, because they are sharing the rewards that that they are getting. But this basically, I mean, it's a sign that we can get to a point where like computing and storage can be so cheap that we are going to be unlocking incredible use cases that today are just not feasible. Because cloud providers today are not charging you like what's actually, they are charging you 10x of what that really costs you, and they are just absorbing those. I mean, in that way, they are basically absorbing the cost that they have for development of the tools and for marketing, sales, and so on, which is not something that we need in a decentralized storage network. By the way, this is 13 times more than what cloud providers had the first year of operations, because 13 exabytes was onboarded in the past 12 months, since that was when the Filecoin network was live for the first time. So it's super fast. We are not realizing that because everything is moving so fast, so we are not even looking at that number that much. But when the cloud was growing, that was like much slower. But yeah, it was long ago. So a bit about like how that looks in the data center. So of course we have like a storage network, and then we have like a data center where we have multiple hosts, and those machines are like very different. Might have like GPUs, some might have like high memory, some are like storage nodes that basically have like a bunch of hard drives that are redundant and have like more redundancy than the other nodes. And people would think that the Filecoin network looks something like that. But actually it's not. Like it takes a lot of effort to get to a point where you can actually have like a committed capacity, which means like that particular capacity is committed by the miner and can be used for some verified storage deal that is basically some data that is useful to the network. Instead, how the data center, so instead like what we have is we have storage, we have proofing, we have sealing, and all of those, of course, have like very different resource requirements. But at the same time, we have, yes. So just to go over like quickly, because some people might not be completely aware of what's happening here. So first of all, we have like the storage nodes that are making sure that like the storage that is stored on Filecoin can be retrieved, and that it is always there. And in case of that not being there, those miners will be slashed. Then we have like the proofing that is being done like every 24 hours, making sure that like the committed capacity that is committed is actually committed, so that has to uniquely prove every 24 hours that all the sectors that he has committed are actually there. And then in order for those two to be possible, the onboarding of the storage needs to happen through the process of sealing. And the process of sealing then has like very different resource requirements, because some parts of the sealing are very high memory, and high frequency cores are required for that because they are single threaded, while others can be many CPUs in parallel or on advanced GPUs that have like CUDA cores. So at the end, we get in a situation where we don't have like anymore just the storage nodes, but we have like a bunch of different nodes running on different machines, depending on the stage of the data center. Meaning that if we have like committed to all the storage capacity that we have in the data center, then we probably are going to have like mostly proofing nodes and nodes that are doing just managing the storage. But if I'm onboarding storage, I need to have like many sealing nodes as well. So from there, where we want to get is to a point where other than just managing storage, we also have computing that is actually like interacting with the storage. So we are going to have some compute network, just to be fair towards all other work, it's going to be a compute network X. And then we basically need a way for whatever is computed on that compute network. And of course, like that compute deal is going to happen on that network and someone is going to pay for that computing resource. Then we need to find a way to efficiently store that on the Filecoin network. So we need to have like a storage and retrieval layer that is actually like managing all the interactions that are happening with the Filecoin network, negotiating storage deals with particular miners based on some characteristics that are important for that customer that is interacting with the computing network, and so on. So we're just trying to decouple like all of those complexities in a way that the computing network or a developer that is actually like building something that needs to be computed on a compute network and stored on Filecoin is not managing all of that complexity himself. So otherwise, it's not going to happen. But the most interesting part is that, the most interesting part is that all of those are going to be running like on the same data center. So like the bandwidth that is available from the compute network to the Filecoin storage network is very high. At some point, if you're referencing data that is already on that data center and referencing those that data through CIDs, you're most likely going to have like orders of magnitude faster computing, depending, of course, on how challenging the compute job is, because you're able to like retrieve it right away from the same local network. A bit about Estuary. Estuary is that retrieval net. It's not yet a network, but it's that retrieval layer that actually allows you to store data to the Filecoin network, but also retrieve data from the Filecoin network through IPFS. And it's also managing the caching of that data. So for example, if you have stored something on Filecoin through Estuary, and that something is being used by particular users, it's always going to be cached on IPFS Estuary, and that logic is managed by Estuary. So you basically, as a compute network, you're not even like aware of what's happening on Filecoin. All of that is being abstracted away by Estuary. So yeah, of course, the importance of having everything on the local network are many. First, because like data is growing so fast that at some point we are going to start hitting infrastructural issues, like in the context of like the amount of fiber that we can dig into the ground is not going to be enough. Like Starlink is not going to be enough. We will need to start thinking about how do we do computing locally rather than always retrieving that from the internet. Especially since data sets are growing, it's becoming practically impossible to like retrieve something in a relatively short amount of time. Yeah, so this is the situation we are now, but with computing, we actually have like different nodes that are running the computing network based on like the resources that are available there. And then we have like the Estuary layer that is allowing, which can also run like on a single machine and talk to the other nodes. But in this particular case, it's running like on each of the machines and managing how that is being written to Filecoin. But other than that, we need to have some logic, which is something that I'm particularly interested about, which I'm working on, that allows us to do some more of those nodes, which means that we need to be able to get to a point where we can receive a particular job, and that job is scheduled to a particular network, which can be multiple networks. And then we get to a point where basically we are thinking about how to maximize the resources that are available to that miner, and how to actually extract most of the value that that miner is providing to the network at this point. Because this is not anymore about Filecoin, it's about all the other networks basically bridging through storage and being able to do computing that at a scale that was not possible before. So why we are doing all of that? Because we want to bring ownership of data to the final users, which is currently not possible with the way that we have structured the cloud and how that is legally being managed. And we want to offer net infrastructure because at some point that is not going to be enough, and we need to be much more careful on how we are using it. And we want to get to a point where we are actually paying for storage and compute that is actually directly linked to the price of storage and compute, rather than prices that are kind of set by cloud providers and getting like big profits on that. And lastly, which is probably the most powerful one, is that we're going to get to a point where we can completely change business models of how like computing and storage are happening, how apps are running on top of those. And some models that we're working on and researching are like, how do we get to a point where we are paying users to actually store data? And if you think about that, it's kind of tricky that we are in a position where we are actually like not paying for anything, but we are getting a lot of data. In a way, we are all paying with that data. That is just not formalized. But because of the way that we evolved in the past 10 years as humanity, we got to a spot where we are basically like giving that, thinking that that is okay. Actually, it makes much more sense that we are being paid for actually using those services, and or actually developers can be paid for storing that data, and they can share with users if their business model is centered around generation of data. So yeah, I hope it did not like make too much confusion in your heads, but if you have any questions, I can answer them now, or you drop me an email at vukasinprotocol.ai.
Dude, amazing. Thank you so much for that presentation on decentralizing the data centers. We have 2 questions from the Q&A, and I will read them through to you. First one is from Anonymous with 4 upvotes. What's the progress of onboarding corporates? Who are the main customers of Google and Amazon Cloud?
Yeah, so there are many stages which you approach that. The first one is you want to make sure that those data centers that are part of our network have like all the certificates that a particular corporate might need. And those are like large storage clients that we have. And actually, we are having a lot of data through corporates, but it's still only archiving. We want to get to a point where those corporates are also like computing something. Maybe you have like a bunch of data of users that you're storing on a particular data center, which you might also be managing as a corporate, which is not possible today because like those are like centralized and managed by AWS and Google most of the time. But in that case, you could like do computation on top of that data, basically offline completely on your data center, and just basically like do the negotiations of those deals on chain. But yeah, like we have a bunch of data centers with like certificates that are required for those corporates, and we have like a growing number of storage clients that are archiving big data sets on right now. But that is not computing yet, unfortunately.
Cool. Next question is also from Anonymous with 2 upvotes. How would CDN networks be managed in a decentralized way? How would the incentives hold up for that sort of data?
Yeah, so basically, in my opinion, one big misconception today is that like IPFS nodes are not incentivized, but for some reason you have like many organizations many are CDNs that are actually like running those IPFS nodes. So there is some incentive. Whether the incentive is on chain or whether it's structured, that's a different story. But the incentive is there, and those organizations are not planning to stop doing that, especially now. How that would be monetized? That's a good question. We are working on like the retrieval network that will, of course, give that structure that everyone is waiting for. But you could also think about models where you could pay for CDNs to like keep like pinned some particular data sets and just do the similar model that they are doing right now. Or you could have like data DAOs that maybe have like some treasury and are getting some yield from DeFi. And basically because of that, they are being able to pay like for the IPFS fees. For that to happen, of course, you need to like bridge fiat is something that Cloudflare would ask you for with those rewards that you're getting from DeFi, but that is part like of that data DAO that is actually managing the data set.
By CDN is content delivery networks, right? That's what that stands for.
Yeah. Plus, what we are forgetting is that we're going to have like many like IPFS nodes on things like routers, on ISPs. It's not just going to be like CDN providers, because it's so easy to like run a IPFS node today that those can be like from being embedded in your client to being like just on the local network, or maybe even like telcos could like integrate them like next to their core infrastructure, and with that like reduce the costs that they have, which are not like small right now.
Cool. And last question, wouldn't lowering the barrier of entry in terms of hardware or infrastructure increase the risk of node failure?
No, actually, you still have to like put a lot of collateral, and the way that I mean, like lowering the barrier is just making it a bit easier for those companies to run it. So instead of like hiring a particular person that is very technical and can actually like do some infrastructure work, you're able to like hire a less technical person, and or even not hire any person and have like their infrastructure running. Because at the end of the day, those data center operators, they are basically just real estate companies. They care about CapEx, they care about fiber, they know how much they are making, and that's it. They don't have tools or what data set is being stored on their infrastructure, which is good. Like we are dividing responsibilities. Someone is thinking about like how to actually make something possible in the physical world. We are like infrastructure above, and we are trying to like provide that software that is going to allow them to contribute to a decentralized network.
Amazing. And that's it for the questions. So thank you for your time and for your presentation on decentralizing the data center. Yeah, like I remember our conversation in that coffee shop was mind-blowing, and this presentation was just as mind-blowing. So thank you very much for your time. Yeah, feel free to stick around and listen to other presentations and talks. I know you're a busy guy. I know you just landed in Helsinki, so.
Thanks, bye.
All right. Thank you.